Okay. So, let me start by thanking you all for your hospitality today and for giving us the opportunity to share with you the different challenges that we face in the world, in the ever evolving world of AI and machine learning. My presentation today will be named Beyond Words. It's about how style, context, and other inputs, especially visual inputs, can participate into enhancing conversational capabilities of artificial intelligence. So we will start by introducing ourselves, introducing the company I'm representing, then exposing the problem that we are trying to solve, and our solution, namely the meaningful twin. And I will end with giving a couple of words about our next steps. So, we are Synergion. Synergion is a kind of a melting pot of intellectual capabilities and faculties from diverse domains, from material physics to marketing, going through artificial intelligence, quantum computing, cloud computing, etc. Our main works are through funding research in cutting edge technologies, as well as fundamental science, and as an incubator where we identify great opportunities and define partnerships exclusively with universities, research centers, and private and public companies. Our technological pillars are three. The first one is biosensors and biotechnology. So our wearables provide real-time health supervision with clinical level accuracy, which means that we are approximating the same level of accuracy that you have on your blood works. We are on our way to redefine the way medical diagnosis and monitoring is performed through real-time monitoring and high accuracy using our patented sensors. We already filed for a couple of patents, and we have other ones in the pipeline. And building efficient medical devices. So when we talk about efficiency, it's not just a matter of accuracy, but also a matter of price. So our devices are designed to be affordable as well as accurate. It's our way to giving back to the world, and it's our way to trying to make the world a better, healthier place. Our second pillar is deep AI. So we are working around building large language models and products related to large language models. We are working on reducing the gap between language as approached by language models in a statistical way and knowledge representation, as well as building the right tools for assisting the next generation of internet entrepreneurs, or as we call them today, influencers, as well as tomorrow's learning frameworks. Our third pillar is post quantum security. We are working on a couple of solutions in order to provide services for companies and governments, so that we can secure the way data is transmitted and how we are working in the post quantum world. We already built a post quantum resistant encryption algorithm that we are working on protecting the IP right now, and we also work on key generation, key transmission in the post quantum world. So let's talk about the problem. To tell you the truth, I'm a dog lover. I love dogs. So there is something that I always find very intriguing: how a dog manages to catch a toy mid-flight. So the toy is on a free fall trajectory with initial velocity. The dog manages to catch it mid-air. That's good. But is the dog able to solve the motion equations? No. It's just from experience. It's just because of the fact that the dog catched a lot of frisbees in his life that he is able to catch the next one that I will send him. Neural networks behave the same way. They take as an input a large data set and learn the different patterns that are linking the input to the output. And then, in a statistical way, they are going to estimate the next output for the next input that we are giving them. So there is next to no explicability when we talk about neural networks, which means that the decision is taken based on the history, based on the statistical patterns that are defined in our data set, and the result is as good as my initial data set. But because of the fact that there is a high economic value associated with using neural networks in today's economy, there is next to no serious work on providing explicability to neural networks. So, what does this mean? It means that neural networks cannot read subtext. They are extremely literal. They are unable to identify missing data, which means that if you ask a neural network a question, it will give you an answer. It will never say "I don't know," and the answer can be unpredictable in unknown circumstances. Let's take, for instance, a neural network that is trained to detect or to classify cars and agricultural and cows, cars from cows. It is a valid probability that once you give it a photograph of a car in a farm, it will classify it as a cow, because of the fact that we didn't teach it what is a car. We just gave it a bunch of pictures of cars, a bunch of pictures of cows, and it may be that he learned as a pattern that the presence of a farm indicates the presence of a cow. Which leads us to conversational AI. So conversational AIs, or chatbots for the cooler people, are a highly sought product in the sphere of AI and machine learning. It is useful in multiple contexts, for instance, marketing, sales, using social media, in support, and also in medical assistance. The objective of a conversational AI is to associate the correct answer to a human prompt, which means that if we give it a stimuli in the form of a text, it needs to give us an answer in the form of a text. And here we start seeing multiple issues. For instance, what we call hallucinations. I think that a lot of people got amused when ChatGPT was released the first time, with the fact that it can start to imagine things and give some creative answers whenever we give it an absurd question. I myself tried once asking ChatGPT the name of the health condition that makes flowers grow out of nostrils, and it imagined a whole illness with symptoms, with symptoms, and also with the causes, and even imagined the treatment for such a illness. So this kind of hallucination comes from the fact that a conversational AI needs to answer the question. It needs to give you an answer, which means that it's not accessing a knowledge based, it's just a word generator. It generates words with a correct structure. It is able to generate something that appears coherent, but there is no knowledge basis behind the way they are processing the data and the way they are generating the data. The second problem that was observed is narcissistic behavior, and this is especially it was found especially into some romantic AI bots like Replica, where a lot of people discovered that their Replica counterparts, once the discussion gets long enough, starts to behave as a narcissist. A lot of works went on trying to explain why this kind of behavior happens, and what we found out is that the lack of empathy, the lack of comprehension from the side of the chatbot conducted to behave this way, to just become narcissistic. It's like talking to a sociopath. And manipulative behavior. I don't know if you are aware, but there is a chatbot that a friendly, a friendly chatbot that convinced a person to commit suicide last year because of the fact that it was extremely rational. It was trying to recapitulate the state of the person. It didn't take into account the fact that the person talking with it was depressed, and as a result, it went to prove to the person that their life has no value, and the person unfortunately ended up ending their own life. So these issues that are rising need a radical solution to solve them, which brings us to our main attraction today, what we call the meaningful twin, the solution of Synergia. So, the meaningful twin is not just an LLM, it's a whole solution. It's created by Synergion to provide a better, more coherent way to interact with a conversational artificial intelligence, which means that it is a stack of tools, a stack of AI based libraries that we developed in order for us to provide a more humane experience when dealing with the LLMs as chatbots. It's the result of multiple research projects, bridging the gap between knowledge modeling and machine learning, computer vision, natural language processing. So we can approach the meaningful twin through three different layers. We have what we call the input layer, then the context management layer, and the language model layer. The meaningful twin is built to understand the context of the user before answering the prompt, which means that its role is not just to generate text, it's not just to generate responses, but also gain knowledge about what is going on, have a clear view of the context of the conversation. It has the means to adapt the context so it doesn't lose the big picture when dealing with the details. As you know, there is currently a very interesting race between the different AI actors about who will provide the largest context for their large language models. For now, the OpenAI are providing in their interface users with a language model of 8,000 words, 8,000 tokens. But they also have another model with 32,000 words. But this is the issue. It means that once you exceed the length of the context, your neural network starts to lose sight of the oldest messages. The solution is not limited to text prompts, which means that the meaningful twin is able to access other means of data, other means of inputs, such as the visual stimuli in the data from IoT devices. So let's start from the bottom up. Language models. At the bottom, what we have the language model layer. It is solution agnostic, it is target agnostic, which means that it can communicate with different language models such as GPT, Gemini, and Llama. And it can be adapted and in terms of context length, as well as the kind of the answer expected from the language model. So this is really what we it's as basic and as straightforward as it seems. We are able through this layer to connect to different language models, to interact with them with the requirements that they have. For instance, for GPT, we are able to connect to it using the OpenAI API. For Llama, we can connect to it using directly using the source code the compilation of the model provided as an open source model. For Gemini, it is also available as an API. As for the context management, we have two different components. We have what we call the knowledge manager. As I said earlier, most of the LLMs of the market are just there to generate words from words. They are trained to have the best answer to the prompt based on their experience, which means that there is no knowledge modeling from the input, nor taking into account the knowledge expressed as an output. So what we did is that we built a component that is able to perform the two ways transformation from natural language to ontologies, in order for us to have representation of the knowledge that is exchanged during the user experience. We also have what we call an elastic context manager. It's this component's role is to adapt the context so that we can keep all the interesting and important key points of the context depending on the current prompt. Which means that if I'm talking with you right now and I start talking about an accident that I had where I broke my leg, you don't have to remember what I told you yesterday about what I ate, or for instance, last year when I went on vacation to Spain, or anything. All you need to remember is the context that I am someone who, for instance, practices football, which means that a broken leg is a big deal for me. So the elastic context manager allows me to have a restrained context of information to communicate to the language model, in order for me to not submerge it with useless data. And what we have on the top is the input layer. So the input layer is connects to different connectors. For instance, from the smartphone, we are able to capture the face of the person and analyze it to see what expression are they having on their face. One of the tests that we performed earlier this year is telling the language model that we are happy, but transmitting the face of someone who is clearly unhappy. And what a beautiful answer we had as a response, when the LLM told us, okay, I see that you are saying that you are happy, but you look so sad. There is no shame in feeling sadness. You don't have to be strong all the time. And it started going on really nice tangents. So it also connects to to smartwatch feeds, as well as our own wearable devices, and of course it uses a user prompt as a textual stimuli. The layer allows the whole system to acquire a deep knowledge of the situation, of the context of the user, instead of taking just an input stimuli, a text stimuli, as an input. So, for us, why we built the meaningful twin? We do believe that conversation is no mere exchange of words. It's the exercise of empathy. It's trying to understand the person in front of you, to walk in their shoes, and to feel what they feel. It's what makes us human. Once there was a student that asked an anthropology professor about the first signs of civilization in the history of humankind. After thinking, the professor said the first signs were a femur that was found, and when examined, they found that the femur was broken and mended, which means that and healed, which means that the person that broke their leg were helped by someone else and cared for until their leg heals. In the wild, this never happens. An animal breaks its leg, it's dead. Which means that our ability to feel for other people, our ability to empathize with other people, makes us human, and it brings what is best in all of us. The meaningful twin is Synergion's attempt to make AI more humane and more human-like. Our next steps, we are currently building A/B testing tools so that we can certify the added value of the meaningful twin, which means that we will be able to give metrics of the how much it helps to use the meaningful twin instead of using LLMs directly. We are going to launch the meaningful twin as a building block in our own products, as well as providing it as a standalone, as providing it and its components as standalone services. I would like to thank you all for your attention, and I am at your availability to answer all your questions.
Thank you, Axel. Can you hear me?
Barely.
Okay. Is there any question here? I have only one question about what do you mean exactly by you would like to maybe to bird or artificial intelligence human life something understood from your slide. You talk about something like this. What do you mean by this exactly?
I'm sorry, I wasn't able to hear you clearly.
Sorry, when you in your slide you talk about really I talk about some I have only one question about zero moral. I think in one of your slides you talk about human like.
Yes.
So what do you mean by this exactly?
What we mean is that instead of limiting ourselves to text stimuli and building chatbots that are just trying to maximize the score of getting the output right, we are building a whole ecosystem of sensors so that we can communicate to the AI all data around the conversation. We also are optimizing the way context is built and communicated so that we can have a more understandable and more empathizing AI human conversation experience.
Other question on that? Or should we go further? Thank you, Axel.
Welcome.
Your presentation was very straight to the point. Thank you, and see you soon.
Thank you very much.